Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking all about significant figures in chemistry and physics, especially chemistry. And so I'm going to be explaining how we count significant figures, also how we do operations with significant figures, such as multiplication, division, addition, and subtraction. So first, let's introduce the topic of significant figures, also called sig figs. Let's say I want to do 10.0 divided by 3.00. And you plug that in your calculator and you get 3.3 repeating. So 3, 3, 3, 3. It goes on forever. However, if I'm counting sig figs, I would actually stop at 3.33. It would not be repeating. My final answer is 3.33, and that's it, because this first term has 3 sig figs and the denominator has 3 sig figs, so my answer needs 3 sig figs. And if hypothetically I had something like 6.666666, and same story, I want to go to 3 sig figs, I would have to round up this time to 6.67. So that's the introduction, but how am I counting these sig figs? So let me explain it by doing some examples. How many sig figs or significant figures does 112 have? Most of the time, we just count the number of sig figs by counting the number of digits in the number. So for example, 112 has 3 digits, so this would be 3 sig figs. Now, what if my number is like a decimal? 16.520. How many sig figs would this be? Well, once again, I'm counting 1, 2, 3, 4, 5 digits, so this would be 5 sig figs. Now, there is a rule when it comes to decimals, but this is a pretty normal one. So later on in this video, I'll show you what I mean by being careful around decimals. Actually, the examples right now. 0.0019. How many sig figs is this? And so the general rule with sig figs is you don't start counting until you get to the first non-zero number. So in other words, this doesn't count because it starts with a 0, then another 0 doesn't count, then another 0 doesn't count. It looks like I only start counting when I get right here. And that 19 basically is 2 sig figs, and that's the answer for that one, 2 sig figs. Okay, but then what if I have something very similar, except instead of 0.0019, what if I have 1.0019? Well, here's the difference. I start counting at the first non-zero number, which is the 1. And then the question is, do I skip these zeros? Do I count them? And the answer is yes. Because this number was not 0, we do count both these zeros. Actually, we're counting all the digits for this one. And so that's why the answer is going to be 1, 2, 3, 4, 5, 5 sig figs. Even though the only difference between this one and the last one was putting a 1 out in front. Okay, now the next one's also going to be a little tricky. The number is just 650. And so if you say 3 sig figs, because there's 3 digits, you would be incorrect. Because the rule is you don't count zeros at the end unless they're past a decimal point. So in other words, I'm counting 6 and 5, that's 2 sig figs. But if I had 65.0, now I do count this 0 and it would be 3 sig figs because it's after a decimal point. But since there's no decimal point, I don't count zeros at the end, and that's just the rule of sig figs. So then just 2 more I want to look at in terms of counting sig figs. How about this one? 70,010. This one has a lot of zeros, but how would I count this? Think about it for a second. Pause the video if you need to. And here's what I would say. The first number, 7, I do start counting, and I only don't count zeros at the end. So in other words, the only 0 I'm canceling out is that one, the one after the 1 there. So in other words, I count 1, 2, 3, 4 digits, which means 4 sig figs for this one. And then finally, one more. Let's say I have 0.03040. And remember, decimal rules are a little bit different. So I start with the first non-zero number. That means I don't count the first 2, and I'm starting at 3. Definitely include the 0 in the middle. In general, we always include 0 in the middle of two other numbers. You always count those zeros. But what about this 0 at the end? Do we count it? The answer is yes, because it is inside a decimal. If there was no decimal there, I would not count the 0, but there is. It's in a decimal. So that means 1, 2, 3, 4 sig figs. And that's all the examples I have for today in terms of this topic. The rest of this video, we're going to be doing operations with sig figs. So let's start with multiplication and division. When it comes to multiplying and dividing numbers and counting sig figs, you always want to use the least number of sig figs. And so what that means is if I want to do the operation 42.0 times 3.6, my final answer is going to follow the least number of sig figs, which is going to be 3.6. That's only 2 sig figs. 42.0 is 3 sig figs. And the reason why is that 0 comes after the decimal point, so I do count it. And so in other words, my final answer has to be the least number of sig figs, so it has to be 2. And so what that means is when I plug this in my calculator and I do 42.0 times 3.6, I'm going to get 151.2, but I have to round this answer to only 2 sig figs, and it has to be the first 2 sig figs. So in other words, that's the 1, the 5, not the 1 here. And so I can't just write my answer as 15 because that's not even close to 151.2. You have to write your answer as 150. And this is only 2 sig figs because remember, you don't count the 0 right there because it does not come after a decimal place. So now it's just going to take some practice to get better at this. And so I have 2 more problems we're going to do today with multiplication and division. The second one is 1.60 divided by 4.000. So when we do this, you first have to ask yourself, how many sig figs is the top one and how many sig figs is the bottom one? Well, for the top one, you do count that 0 because it's after a decimal. So that's 3 sig figs for the top one. And for the bottom one, you count all these zeros because all of them are after a decimal place. So that would be 1, 2, 3, 4 sig figs. And so in other words, when I do this division, I need 3 sig figs because that's the least number of sig figs. So I do 1.60 divided by 4.000 in my calculator, and I will just get 0.4. But if you write 0.4, this is not the right answer because that's only 1 sig fig. And like I said, I need 3 sig figs. So how can I add sig figs to my answer? It's easy. You just add 2 zeros at the end because remember, we do count zeros at the end of decimal places. And so now we have 3 sig figs. And 0.400 is the best answer here. And now I just have one more with multiplication. And it's 0.086 times 5.0. So why don't you try this one on your own? Tell me how many sig figs are in each number. Then plug it in your calculator and tell me what the final answer will be. Okay, and here's the solution. So the first number, I don't count these zeros in front. So I start with the 8, and that's 2 sig figs. And 5.0, I count both of these, so that's, again, 2 sig figs. So in other words, my answer is going to be 2 sig figs. No surprise there. When I do my actual multiplication, I should not be crossing out those zeros. I should be including them when I type it on my calculator. Just my final answer I need to be careful of. Anyways, I got an answer of 0.43. Which is already 2 sig figs, so I don't need to change anything. And so that means just 0.43 is my answer, and we're done. Now that we're good with multiplication and division, let's talk about addition and subtraction with sig figs, because this is going to be a little bit different. So first, the rule with sig figs, I'm not counting sig figs actually at all. I just need to use the least decimal places. And so what I mean by that, if I have 3.22 plus 6.9, then what's the least number of decimal places? It's 1 with the 6.9. So when I plug this in my calculator, 3.22 plus 6.9, and I get 10.12 as my answer. This is not my final answer, because I need to stop at one decimal place. Always use least number of decimal places. So I round to one decimal place. That will be 10.1, and 10.1 is my answer. So again, I don't even care about the number of sig figs exactly. It's all about the decimal places. Let's do a couple more. How about I have 6.34 plus 0.509? What would this be? Go ahead, you can pause the video, try it on your own first, and then unpause it when you're ready to see the solution. Okay, so the first number is 2 decimal places, and this number is 3 decimal places. So since I always use the least number of decimal places, I am going to keep my answer to 2 decimal places. So I do 6.34 plus 0.509, and I get 6.849. But since I only want 2 decimal places, I need to round to here where I underlined, and that's going to round up to 6.85, which is my final answer there. Addition and subtraction is, in my opinion, a little bit easier than multiplication and division. And finally, just one more for today. Let's say I have 18.9604 minus 3.03. So again, pause the video, try this one on your own first. And here's the solution. The first number has 4 decimal places, and the second number has only 2. So I know when I get my final answer, I need to keep it at 2 decimal places. So then it's 18.9604 minus 3.03, giving me 15.9304. But since I only want to round to 2 decimal places, looks like my final answer is 15.93, and that's it. So that's going to do it for today's video on sig figs. Thank you all for watching. Have a great rest of your day, and I will see you in the next video. Take care, and bye-bye.